Welcome to this class. Now, in this class, I'm going to consider classes of matter in chemistry. Generally, in chemistry, we have three classes of matter. So, the first is element. Secondly, we have compound. And thirdly, we have mixture. Now, in this video, I'm going to define each one of them and give examples of each as many as possible. Let's go. Let us start with element. Before that, I must let you know that both element and compound are known as pure substances, while mixture is called impure substance. Now, the pure substance is also known as distinct substance. Generally, a pure substance has the following characteristics. First, all the parts are the same throughout. There's no differences between its parts. It is homogeneous. That's the meaning. That is, it's made up of the same kind of compound. Everything is the same throughout its entire body. So, element and compound have this kind of characteristics, and that's why they are called pure substance. For example, look at sulfur, which is a good example of element. You can see that all of its body parts are the same throughout. It means this is homogeneous throughout its entire body. No part is looking different from the other part, so it means it is a distinct and pure substance. Take another example. Now, this is salt, which is sodium chloride, NaCl. So this is another example of a homogeneous substance, which is a compound, and it is a pure substance. It's a pure and distinct substance because all its body parts are the same throughout. So the element and compound are a good example of pure substance. Let's see another characteristics of pure substance. Another property is that composition of a pure substance is definite. So this happens for both element and compound. Their composition is always definite. But for an impure substance, the composition is not really definite. They can be mixed in any proportion. So, but for compound, for pure substance, for instance, look at the sodium chloride, which is NaCl. You will see that we have one atom of sodium mixing with one atom of chlorine to form sodium chloride. So it cannot be mixed in other way. They must be combined in this manner. Now, consider water as another example, H2O. You will see that in the combination, we have two atoms of hydrogen and one atom of oxygen. So they cannot be mixed in another way. So every water molecule must have two atoms of hydrogen and one atom of oxygen. So you can see that the composition is definite. And this doesn't happen for impure substances, which are called mixture. It doesn't happen like that. For instance, the solution of sodium chloride in water, this can be mixed in any proportion. At times, you can have more salt than the water, while at times you can have more water than salt. They can be mixed in anyhow. Now, another property of pure substances is that they cannot be separated into simpler substances by physical means. It is never possible. So, if you take, for instance, the sodium chloride, which is a combination of sodium and chlorine, this combination cannot be separated. We can't separate our sodium and separate our chlorine. This has to be like that permanently. And also in water, we have H2O. This cannot be separated at all unless we apply our electrical method, which is electrolysis. So by physical means, it is never possible. That's why they are called pure substance, because they are mixed homogeneously, because they are pure substances. So they combine together to form one unit. So they cannot be separated easily like that by physical means. Another property is that they have a unique set of physical properties, such as boiling point, melting point, density, physical state, etc. So what we are saying about this is that every pure substance have unique set of physical property, meaning that when something is pure, its boiling point is always fixed. You always have a particular boiling point without any alteration in it, unless if the substance becomes impure. That's when we can be having problem in the boiling point. For example, a pure water, a completely pure water, an entirely pure water boils at 100 degrees Celsius. But when the water contains impurity, the boiling point will be increased to something higher than 100 degrees Celsius. It can boil at 105 degrees Celsius or 110 degrees Celsius, depending on the amount of impurity present. Similarly, the melting point of ice, I mean a pure ice, is 0 degrees Celsius. So that's one of the property of uniqueness, of the uniqueness of it. Because a pure ice, once it is still pure, it will always melt at 0 degrees Celsius. But once it is no longer pure, then it will melt at lower temperature because impurity decreases melting point. So that means an ice that is supposed to melt at 0 degrees Celsius will end up melting at maybe minus 5 degrees Celsius or minus 10 degrees Celsius, depending on the quantity of impurities present in it. Another thing is density. Consider the density of water. The density of water is 1,000 kilogram per meter cube or 1 gram per centimeter cube. So this is the density of the pure water. And this density can change if there is impurity in the water. Now, another thing is physical state. For example, water, the physical state of water is liquid. Water is always a liquid, as in pure water is always a liquid. And pure ice is always a solid. So they have uniqueness in all of these things. That's what makes them pure. So a good example of pure substance is element and the mixture and compound. Both elements and compound are pure substance. Why mixture is an impure substance? So let us define each one of element, compound, and mixture briefly in this video. Now, let's consider an element. Element is commonly defined as follows. An element is a pure substance that cannot be easily split into smaller substances or into simpler units by an ordinary chemical process. So the definition is as simple as that. Now, common examples of elements are hydrogen, which is H, the symbol for hydrogen is capital A. Another common example of element is carbon that has the symbol C. Another example is iron with the symbol Fe from its Latin name ferrum. Another common example is sodium with the symbol Na from its Latin name natrium. Another common example is chlorine, which has the symbol Cl. So we have several other examples of elements. The table that contains all the elements of the world in order of their atomic number, in order of their increasing atomic number, is called the periodic table. So the periodic table contains all the elements that are discovered and manufactured artificially over the years. Altogether in the periodic table, there are about 118 elements. Now, this is a typical periodic table. You can see that the first element in the periodic table is hydrogen with the atomic number 1. And the last element in the periodic table is the element with the atomic number 118, which is organicium. Don't mind this set of elements that are separated out. They are known as the inner transition elements. They are brought out from the lanthanide and actinide series. You can see that from 57 to 71 are removed from this particular column. And then from 89 to 103 are supposed to be here, but they are removed from this particular row. So that means the arrangement still goes the same way. Organism is still the last element in the periodic table, which is the atomic number, which is the element with the atomic number 118. So in general, in the periodic table, we have 118 elements. This arrangement is according to Abraham Henry Moseley. And this is quite different from what Mendeleev first brought, because in Mendeleev periodic table, we arrange elements according to atomic mass, and there is a lot of gap inside that. Then this modern periodic table is based on the arrangement of Moseley, Henry Moseley. Now, for every chemistry student, it is very important to master the first 20 elements in the periodic table. That's from element number 1, which is hydrogen, to element number 20, which is calcium. So it's very important to master them together with their symbol and their atomic number. Let's present that in a tabular form. Now, on this page, we have the elements from number 1 to number 10, from the atomic number 1 to atomic number 10. So we have hydrogen with the symbol H and the atomic number 1. Then helium, which is He, then lithium, Li, beryllium, Be, boron, B, carbon, C, nitrogen, N, oxygen, O, fluorine, F, neon, Ne. So, and the atomic number of neon is 10. Next, we have sodium with the symbol Na and the atomic number 11, magnesium, Mg, aluminium, Al, silicon, Si, phosphorus, P, sulfur, S, chlorine, Cl, argon, Ag, potassium, K, and finally the 20th element with the atomic number 20 and the symbol Ca is calcium.